All right, well, thanks everyone for joining us today for the webinar. This is our NFV, SDN, and Cloud When, Where, and How Deep webinar. My name is Dan Meyer. I'm Editor-in-Chief at RCR Wireless News. For today's webinar, it's a 1-hour webinar. We will have a couple of presentations. I'll give a quick overview of a report we recently are getting ready to put out on the topic. We've got analyst Ian Gill to join us as well to give some insight from an analyst perspective on the topic. And then we got a couple of panel members, Mick Conrad and Raymond Chu from Sonos and from local backhaul networks, to talk a bit about their product offerings. And then we've got a roundtable discussion that we'll use some questions from those in the audience who might have on the topic that we can discuss. And that'll be for about the last 20 minutes or so of the webinar. All right, well, here's a quick overview of the about RCR Wireless News. We've been covering the wireless telecommunication space for looks like a little over 30 years here, so for quite some time, focusing more recently on the software space. Again, this is all a part of a kind of a report we recently are getting ready to put out. Actually, it should be on our website later on today, looking at the NFV, SDN, and cloud space. Again, you can go to the rcrwireless.com site and download the webinar, and like I said, it should be on the site here shortly. Again, my name is Dan Meyer, Editor-in-Chief at RCR Wireless News. I'm going to go over a quick overview of that report, providing some insight of what we found and kind of some of the reporting we've been doing on this topic. And like I said, we'll have some of our panel members come on a little bit later to provide some more insight as well into the topic. One thing too, we'll try to speak as loudly and clearly as we can on the webinar here. If for some reason we're not coming through too clear for you, please make sure to check the audio settings on your computer. And also, if you've got any questions during the webinar for myself or the panel members, there should be a questions tab there that you can use to send those questions in. And like I said earlier, we'll get to those questions at the end of the webinar as well. So let's start with some of the topics here that we were looking at the webinar. So the basics for this report that we did was just kind of getting a progress report on NFV, SDN, and cloud deployments in the telecom space. Obviously, these technologies have been around for quite some time in the IT and data center world, but over the past couple of years have been getting a lot of recognition for the telecom industry. Since covering this over the past couple of years, it was kind of interesting to get some insight into where we were in terms of the deployment cycle of this. It did seem like 2014, a lot of talk that 2015 would be a big year for POCs and actually some commercial deployments. And it did seem like we did see some of those, though perhaps not to the level that many were expecting. I know some reports came out kind of looking at where we were last year, and it did seem like that perhaps 2015 was not quite the deployment year that some were expecting, and instead looking to see some more POCs last year and into this year as well, with some plans to move into more deployments moving to 2016. I know recently AT&T came out and mentioned that they had, I think, surpassed 5% control of their telecom network using NFV and SDN, which was a bit ahead of their original schedule, but they're still looking to get to 75% control by 2020. So we're still early in the process, but looks like there are at least some of the faster moving operators do have some big plans for moving forward in the space. As I mentioned earlier, so yeah, some reports came out this year kind of talking about, I guess, where we were in terms of 2015. Again, a lot of commercial pre-deployments were being worked on, but again, on the commercial side of things, it's still somewhat limited. TBR had said that they expect a majority of operators to continue with POCs throughout the year as they work towards working through some key questions that still need to be kind of answered in terms of deployments. Again, this move towards NFV and SDN for telecom operators is a pretty big shift for a lot of these companies that have traditionally relied historically on hardware to control a lot of their operations. And so this move towards software, while probably not a huge deal for a lot of companies that have been history in the IT and data center space, for the telecom space, it's a very big move, wholesale change really for a lot of these companies. And so there is a lot of work needs to be done in getting these platforms to move throughout the telecom network. So expect a lot more work to be done there coming through this year and moving forward. As we mentioned, some of the in the report also looked at some of the analyst predictions on what we're looking to see spending-wise in terms of NFV and SDN. IHS last year predicted there'd be a big surge in spending, I think hitting 2.3 billion last year, up to 11.6 billion by 2019 in terms of the global market for NFV hardware and software. So again, a large market ahead. This has drawn interest from a lot of different companies looking to get into the space. So we expect quite a bit of spending to ramp up in terms of deployments. The IHS also mentioned that they're likely to see we're still early in the transformation process, which they said could take anywhere from 10 to 15 years. So like I mentioned earlier, we're looking at a long-term process here, again, very early in it, but it does seem like most telecom operators are pretty dedicated to this, so this is going to be a long-term plan with a lot of spending going forward. Another topic that was brought up from IHS was revenue from outsourced services geared towards NFV, which projected to hit to rise 71% annually from 2014 to 2019, with revenue from software-only video content delivery network functions for managing and distributing data forecast to grow 30-fold between 2015 and 2019. So obviously, where we're at now is pretty much just the beginning of where we expect to go over the next few years in terms of NFV spending for software. Let's see here, next slide. Some more numbers. A recent report from ACG Research found that mobile operators would begin saving money on NFV deployments within the first year and realize an investment payback within 3 years. So that kind of showed that those operators that are getting into the space quite early could expect to see a return rather rapidly in terms of getting the payback from these investments, which will be quite large going forward. Also, adopting a virtualized evolved packet core can reduce capital expenses by an average of 68% and operating expenses by 67%, according to the ACG research. And also, the deployment of virtualized network components can happen within 6 months compared to an average of 15 months for traditional network hardware, resulting in that quicker turnaround time, both for the ROI and also time to market for new services. A lot of companies have talked about the fact that they want to be able to be more agile in rolling out services, and obviously using software to do that is one of the components to allowing telecom operators to compete more efficiently and effectively against over-the-top operators out there, players out there. All right, so one of the issues we found was there's still issues when it comes to the vendor integration challenges for operators. The research showed that suppliers are viewed differently by network operators and IT departments, which is kind of forcing those entities to look at new partners for their technology requirements. This has kind of been an issue where telecom operators have traditionally used some of the big name companies, vendors out there for a lot of their projects. But when it comes to software, a lot of those providers are perhaps a little behind when it comes to getting software solutions out there. And so operators are having to look to some of the smaller, more agile companies to provide their software solutions. And that's become kind of resulting in a bit of a challenge a lot in integrating some of those companies together. That's obviously been showed out a lot when it comes to interoperability and standards issues as well, which we'll talk about a little bit later. But there's still a bit of a challenge for operators when it comes to bringing in some of those new partners to work with some of the legacy partner vendors in terms of rolling out their software solutions. As mentioned by one of the companies we talked to, this favoritism is seen as limiting the overall potential efficiency gains from some virtualization deployments. So operators are having to quickly realize, if they want to gain as much efficiency as possible from their virtualization deployments, they need to get their vendor partners to be on the same page to work together on this. Let's see here. All right. Now, also, we looked at some of the companies that were leading by example in terms of the fast-moving operators that are working pretty aggressively towards the deployments of virtualization across our platforms. I think we've all heard and seen some of the moves by AT&T, by Verizon, by China Unicom, SK Telecom, Telefonica, and Docomo in terms of their moves towards virtualization. These companies have really been at the forefront of really pulling the industry along in terms of their plans for NFV and SDN, and in turn really kind of bringing along their vendor partners as well. This has been a bit of a challenge because traditionally the vendors have kind of driven a lot of the new technology, but now it seems like the operators, when it comes to virtualization at least, are being a big driver for this, and a lot of these companies are not waiting perhaps for some of the standards and interoperability issues to be worked through. And so we're seeing initially here some challenges in terms of some of these companies driving their technologies that perhaps in the long term might require maybe a little bit of backtracking and making sure that everybody can be on the same page, either using open source or different platforms to make sure that there's no interoperability challenges going forward. So that'll be a challenge moving ahead. And then obviously there's a second group of companies out there that are, I guess we can call them watchers, aggressive watchers. And these are those who are perhaps maybe don't have the financial resources to jump early into the virtualization game, or are companies that are looking to maybe longer term gain some cost efficiencies by being a second to market or third to market in terms of this, or obviously they could also be companies that are pretty happy with where things are going now. I mean, a lot of companies, at least here in the U.S., a lot of small and mid-sized operators are just still in the midst of rolling out their LTE networks, are fairly happy with how things are working, and so they don't see much of a need to make a wholesale change towards virtualization at this point. And so they're kind of just letting the market progress and expect at some point to perhaps jump in longer term. But at this point, a lot of companies are just kind of watching the market develop. Let's see here. Now, one thing we looked at as well is what's being virtualized at this point by some operators. A lot of the companies we talked to for this report noted that a lot of these early deployments have come from what they're calling the low-hanging fruits, or areas of the telecom network that are somewhat easier to manage and more segregated from core operations in case something might go wrong. That was talked about. A lot of these areas include the evolved packet core, session border controls, IMS, diameter signaling controllers, and also some VoLTE and voice over Wi-Fi services. These are parts of the network, like I said earlier, that can be kind of somewhat hold off to the side. So in case something does go wrong, there's not a huge impact across the entire network. So again, we're very early in the process. Carriers are very interested in doing a lot of these virtualized deployments, but they don't want to interrupt their current legacy operations, which are still generating a lot of revenue for them. So it's still very early in the process there. One of the things, as I mentioned earlier, hurdles in the way of progress. Again, what seems to be some great business models surrounding virtualization, there are still these barriers in place. Two of the more significant ones that we touched on were interoperability and standards. As Verizon had mentioned, obviously the pace of SDN and NFV deployments could be more aggressive, but they'd mentioned that there's still just some of these challenges in terms of making sure that everybody's on the same page in terms of where we're going when it comes to these standards and interoperability issues. Some of those issues that were brought up include the IP issues, making sure that legacy and new entrants into the space are on the same page, at least when it comes to the standards that they're using and the platforms that they're using. There's also various parties working on separate pieces of the puzzle. I think we're all pretty aware of all the various organizations that have popped up over the past couple of years, working on various aspects of virtualization, whether it's the OPNFV, Open Daylight, OpenStack. I mean, various ones that are out there that are all working towards the same end goal, but they're kind of slicing up different pieces of the pie at this point, and hopefully at some point those pieces will all come back together to form that whole pie again. And also, as I mentioned earlier, carrier deployment plans are outpacing the standards bodies. I think most people are looking towards ETSI to kind of provide the overall standards platform for the move towards virtualization. But as most of us know as well, these standards do take some time, and operators, as mentioned earlier, are moving quite aggressively towards this. And so there's a bit of a challenge right now where we have a lot of operators moving pretty aggressively in terms of their deployments using perhaps non-standards-based platforms, which at some point will have to, I guess, be integrated with what the standards are going to be. So that's still a bit of an issue that's perhaps hindering some of the deployment of NFV and SDN in the market today. All right, well, there's my quick overview. I wanted to go as quickly as I could so we can get to our featured speakers as well. And as I mentioned earlier too, as we go through the webinar here, if you've got any questions for either myself or for our panel members, please make sure to use the Q&A tab there on the panel there to send those questions in. And like I said, we'll use the last 20 minutes or so to go through some of those questions with our panel members. But with that, I want to bring on Ian Geld, who's the president and founder of IGR, to provide a bit of an analyst overview of the topic. So Ian, thanks for joining us for this webinar. We appreciate it.
No problem. Thanks, Dan. So I've just got 3 or 4 slides here, and Dan and I were joking earlier that I've got the pictures, he's got the text. So I've got the colors in here. Yes. But what I want to do is, obviously echoing a lot of what Dan said here, virtualization has been actually a very interesting path for the mobile industry, I think, and it really kind of typifies what we've seen in other areas of wireless. And what I mean by that is, in wireless, we're famous for, things are taking longer to implement than we expect. So location-based services, we're waiting for them for 2 or 3 years. They took 8 to 10 years. And there's plenty of mobile payments, another example. We thought it'd be around in a couple of years, took 8 to 10 years. And I think the same applies here to virtualization. the idea that we were going to jump into this very, very quickly, that all the operators would start ripping out their packet cores and data centers, whatever, and virtualizing really hasn't happened. It is difficult. There's various reasons for it, as you discussed, but we are seeing progress. It's not like there's nothing happening. It's just happening more slowly on a global basis than we would expect it. So this first slide here, what I want to do here is really show, I kind of took a mobile network here and massively simplified it. Obviously, there's a lot more connections and backhaul and things like this and boxes than shown on here. But this is really a logical view of the network. So going from the left to the right, we've got the radio access network. Obviously, the UE is the user equipment, so your smartphone, basically. And obviously connects over the air to an eNode B, which obviously is the base station, cell tower, etc. That connects then on the user plane to an S gateway and then to a P gateway. So the S gateway is really the serving gateway. Think of it as a very big router or router. That's basically where your traffic goes. So the traffic, your FaceTime session or your eBay request or your Facebook update, whatever it is, goes through the S gateway, is then aggregated at the P gateway, and then through into the operator services or into the internet. So those operator services would include IMS, for example, IP Multimedia Subsystem, where your VoLTE would sit, and rich communication suite services, video chat, those types of things. The control plane on the top, the MME actually controls kind of your movement through the network, if you like, and kind of coordinates all the base stations. And then the HSS is actually the old HLR, what used to be called the home location register and visitor location register. But essentially, this is the big subscriber database. So this says, you know, Ian Gillett is a subscriber, he has an iPhone, and he's allowed to do the following things on the network. Dan Meyer is a subscriber, he's an Android user, and he's allowed to do the following on the network. So it's kind of if you think of it, the controlling database. And then the other important one is the PCRF, which is the policy control resource function. That basically is the one that says, hey, you've exceeded your limits. You're not allowed to do this. So for example, if you're on a prepaid data plan, let's say you've got 10 gigs for the month, when you get to 10 gigs, it's the PCRF that will actually shut you down. It tells the P gateway, no more traffic for Ian. And also you can see it's linked into the services. So that's essentially how the networks work. Now if we go to the next slide, I kind of break it up a little bit here for virtualization. So what you can see we've done here is on the user plane is that S gateway and P gateway are now split. And essentially the top two boxes there are the control, and the SDN version is the hardware, if you like, on the for the S gateway and the P gateway. So we can virtualize our packet core. And as Dan mentioned, this is a kind of a popular area to look at for virtualization. The reason being that S gateways and P gateways are really very big routers with a specialized software load on them. So whereas a radio, a base station is very specific to the mobile industry, the S gateway and the P gateway to an IP engineer look like big routers. They look like a lot of things you see in regular data centers. And so for that reason, it's been a popular choice to look at for virtualization. Also, you know, obviously they're very big. There's a lot of traffic flows through those, you know, for that reason they can be very effective in reducing costs. And Dan gave some numbers previously in his comments. Yep. The red boxes on the top also, you know, as I mentioned, the HSS, let's take that as an example, is a great big database. And so databases obviously can be virtualized. They've been done in many industries for many years now. and there's no difference here. So again, some of those control plane functions we can start to virtualize as well. And that's the good news, okay? Now, if we go to the next slide, let's kind of look at this, and this slide's going to build, and we'll just keep it at this one for a second here. And this is going to start presenting some of the problems with this. So if we go from right to left, a carrier typically has a national data center. Packet core sits in there, the OSS, BSS functions, the billing systems, the customer care systems, those types of things. And you know, the number I've got here is 5. So take a big operator, a nationwide operator, they're typically going to have 5 or so of these big data centers, maybe a few more, maybe a few less. The next level down is you get into a metro data center. So somewhere like Dallas-Fort Worth would have one, Austin would have one, Houston would have one. So in a big state like Texas, maybe there's 4 or 5 of these. This actually shows 100. Think of it as the top 100 metro markets, each having a regional data center there. And in there sits that policy control function and the P gateway. That then goes down to a local data center, used to be called a central office in the old days. It could also sit somewhere in the cloud these days. And typically have 1,000 of those. So I live in Austin, Texas. We do have a metro data center here. And there's probably typically 3 or 4 of those local data centers, maybe a few more that roll up into that metro center. So 1,000 or so across the US will be typical. I think a large network like AT&T, and I'm not just talking AT&T wireless, but all of their network, I think they have 4,600 central offices. But obviously that's everything. Then we go out to radio access network. So remote radio head on the top, the macro cells, and then the metro cells, small cells. Well, there's 250,000 cell sites in the United States. Carrier like AT&T has about 60,000. Verizon has about 50,000 cell sites. And of course, they're putting out small cells. And in a few years' time, we're going to have a couple of 100,000 of those. So whereas we count data centers in tens and hundreds, we count cell sites in hundreds of thousands. And that adds a scale problem. So if we go to the next slide. So now we can say, okay, so I've got 5 data centers. They look like regular data centers. I can get in there and virtualize that. That looks pretty good. Now go down to those metro, those top 100 markets. That's a good target for virtualization as well. I can manage 100 sites, 100 locations. Now I get into those local data centers, central offices. Now I could have 1,000 or 2,000 of them. Much bigger scale, much harder to virtualize, just purely because we've got so many more to go after. And the hardest thing, the long-term virtualization, is the radio access layer itself, the RAN. So replacing all of those base stations, all those small cells, is a lot of effort. And frankly, that's the hardest to get to. It also has potentially the highest potential savings. But you know, the idea of going to 50 or 60,000 macro cell sites, ripping out the radios, virtualizing them, putting the basebands back in the data center, et cetera, using Cloud RAN, all the things we can do, that's a huge exercise. Rather, what we do is we wait until we're ready for a major upgrade, for example, 5G coming next, and then look at the virtualization options there, okay? So go to the last slide here. So this is a bit more of a technical diagram, same thing about the network here, but really wanted to show, kind of highlight the areas that we really do see for virtualization and what's happening. So the first one up, you'll notice we're going to shade click the slide, there we go. So we're going to shade that IMS and operator services. And what we found is that a lot of carriers, you know, they want to put in an IMS solution. Virtualized solutions are available today from multiple vendors. You can put in a virtualized solution. What we also find is that while those virtualized solutions may be available, You also find some vendors who still have incentives in place to sell you a box of old iron because the long-term maintenance contracts on those are very, very appealing for long-term revenue for a vendor. So just because the vendor offers a virtualized solution doesn't necessarily mean that the sales force or the business guys are going to sell it to you as a small operator. So something to watch for is, just because you can doesn't mean you will. The next area we go on to here is that HSS, the PCRF, the AAA accounting authorization server there. Now, those are things that they're databases, they're big servers, policy servers, big area for virtualization as well. And we've certainly seen that as well. The next one serving, is the MME, starting to get that, but a little bit further out, there's a lot more of those, obviously tied into the RAN. And then the serving gateway and the P gateway, as it said, the parts of the packet core. The problem there, and Dan mentioned this, is that's where your revenue flows. If your P gateway goes down, you're going to lose or cut off service to a lot of people in a lot of different states, and they're not going to be very happy with you. So the revenue risk from virtualizing the P gateway and the S gateway is actually very, very high. The revenue risk to doing something like the IMS services, and maybe you lose VoLTE in a market or two, is a lower risk. So that has to be weighed against the benefits here. And then the final area, of course, is the RAN, as I said, the eNode B, and doing that. One final point I'll make, the numbers Dan gave earlier on the savings, the OPEX and CAPEX savings from virtualizing the packet core, similar to what we've seen in our research. The problem is, from a mobile operator's perspective, most of the cost is in the radio access network. The packet core actually is only a minor part of the expense curve. The big expenses in those base stations and those radios. So the real benefits of virtualization here in the long term are going to come when we can virtualize that radio access network. So with that, I'll be quiet and hand off.
Great, Ian. Thanks for the great insight. And obviously, like you said, you're focused a lot there on the mobile network, which is a big challenge for all of this. And like you said, it's one of those processes where the greatest efficiency or the greatest monetary gain is going to be the most difficult to pull out of the network. But that'll be for all the smart people to figure out at some point down the road. But with that, I'm going to bring on now Mick Conrad from Sonos to talk a bit about what his company is doing in this space quickly, and then we'll bring on Raymond Chu from local backhaul networks as well to talk. But Mick, hey, thanks for joining us today as well. We appreciate it.
No problem. Great to be here. So I want to talk to everyone a little bit about Sonos first, just a quick overview. So Sonos, we enable and secure real-time communications at scale. So we're in the audio and video session business, and keywords there are scale and securing. So we can support tens of thousands to hundreds of thousands to millions of sessions over our solutions, be they virtualized or appliance-based. And our vision is all around bringing fine-grained session and network policy to enable security in the real-time cloud. So we bring that through our virtual applications as well as our appliance-based products. Go ahead. So here's our product portfolio. If those of you that aren't familiar with Sonos, our core product is our session border controllers. And as you just heard from Ian, that's one of the first places, or I think maybe Dan, that was in Dan's section. That's one of the first places that we're seeing operator uptake in terms of a virtualized application as they move from their current paradigm of appliance-based networks. But Sonos has virtualized a variety of applications around WebRTC, a policy server, around our element management server, around something that we call Velos, which is an SDN a network operating platform for people that are moving into the SDN world and want to link it to their real-time communications environment. And also in the diameter world with our DSC. So what you see here is a couple of the same areas that Dan and Ian talked about as places where operators are first looking to virtualize, one being the SBC, another one in the diameter area, And then, of course, things like SDN, which almost by their very nature are virtual. Right. This is sort of motherhood and apple pie, but I wanted to just do an overview here. That as you move into a virtual world, there are different layers and different things that people are doing. And I wanted to sort of paint people a picture of where Sonus is playing in this world. So you have NFV infrastructure, which is all about. So if you start at the bottom there, so virtualized network infrastructure, virtualized storage infrastructure, virtualized compute, and you see some of the players in the service provider market there. Then you move up a layer to the VNF layer, right, which is where your actual virtual applications sit. And then to the right of that, the virtual network functions manager that works in conjunction with a service orchestrator to manage those applications. So it's important to have both a VNFM, so virtual network function manager, that works to, for example, get statistics from an SBC virtual application or a diameter virtual application. But then there's this service orchestrator. So it's also very important to be integrated into an ecosystem of service orchestrators. And we've seen that a lot of service providers are looking at things like the Juniper orchestrator, Overture, Dorado. There's HP has an orchestrator. There's a variety of them out there. So practically speaking, as when you're looking to move into this whole world of virtual network functions and you're looking to virtualize in a point pop or as Ian was talking about in one of your big large data centers, a PCSCF or an SBC function there, you have to make sure that it's integrated into some sort of overall service orchestrator environment. Not that a lot of people are doing that right off the bat in terms of actually using a service orchestrator, but most people, to really see the full benefit of moving to a VNF environment, will eventually want to orchestrate services automatically. So that's why it's important to make sure you are at some point integrated into some sort of environment. All right. Now, to the core of the topic here of what are we seeing in terms of service provider adoption of NFV. I completely agree with what was talked about earlier, that this is a 5 to 10, maybe in some cases 15-year process with some very early adopter customers that are just going all in on it. And I think Dan showed the list of those. Now, what we see is that a lot of the service providers that are very interested in moving to a virtual environment, where they're first starting to look at this, and this goes back to Ian was just saying, where is there the least risk to both their revenue as well as the biggest bang for the buck from an operations perspective, right? Where by going virtual do they see the low-hanging fruit? One of the places that we've seen is actually in the virtual CPE space. And there's two different deployment mechanisms that we've seen here. One is around taking, and the left-hand side, which is taking virtual functions and putting them onto a box, and putting that box onto the customer premise. And what this allows them to do is that box, and let's call it a server, that server can host multiple different virtual applications, in which you see the little icons there, an SBC application, potentially a data firewall application, even a router application. But because they're putting that onto the customer premise, they manage that, and it's really an extension of the service provider network onto the customer premise. And they can put voice, video services as well as other services through that pipe. But they manage it, and then because it's directly linked through VPN back or MPLS directly to the service provider network, they can also orchestrate all the functions that are on there. So it really becomes an extension of the service provider network onto the enterprise customer premise. And that obviously, and it saves truck rolls, management expense, and worst case, as to what Ian said, if something goes wrong and blows up, the box is, it's just one customer. You're not taking out your entire network. Now, go to the right-hand side. The other place where we're seeing, yeah, that's fine. The other place where we're seeing a lot of interest is in this concept of taking all these virtual functions, hosting them in the service provider cloud to provide the same application functionality to the customer, right? They're still getting a firewall, an SBC to protect their voice and video and do interworking. But instead of being in a CPE that is on the customer premise, they are now hosted in the service provider cloud in a data center and being provided through an MPLS pipe to the customer. But there's still dedicated instances that are orchestrated to come up just for that specific customer. So you have, instead of having one multi-tenant instance of an SBC, you might, and you have 6 customers off of that, you have 6 instances of a dedicated SBC. And this way, each customer still has what they feel is their own protection and their own functionality dedicated just to them and configured specifically any way that they want it. And again, there's obvious cost benefits as well as delivery benefits in this model. So those are the 2, I'd say, low-hanging fruit. We're definitely seeing people move to VNF and moving to this NFV world in the service provider space. We're seeing it first around our SBC product, I think, which jives very nicely with what I think Dan and Ian were talking about. And this is the use case that we're actually seeing people, unless they're really going all in, like that list of service providers that we talked about earlier, most of the other people are dipping their toe in and starting with something like this.
All right, very good. Well, definitely appreciate the insight there, and obviously I am probably the worst person controlling the slides, but I thought that as well. But again, thanks for the insight on that. I also want to remind everybody who's listening in too, if you got any questions for any of our panel members here, to please make sure to use the Q&A tab there to send those questions, and we'll try to get to those in the last 20 minutes or so of the webinar here. But with that, I want to bring on Raymond Chu from Local Backhaul Networks to talk quickly about his company as well. So Raymond, thanks for joining us. We appreciate it.
Yep, thank you, and thanks for having me, and thanks for everyone for joining in. And as Dan and my fellow panelist constituents mentioned, that a lot of the carriers out there are looking for the low-hanging fruit, the mobile backhaul, packet core, as Mikola just talked about, the virtual CPE side, because they're simpler to virtualize, and also the big concern is the risk. And I think the carriers also are facing another challenge, which is oftentimes not talked about that much, which is that their end customers, because of virtualization, need more assurance that the services that they're getting are as good, if not better, than the legacy systems. And that's really where I just want to talk a little bit about our Ocker IP solution. Really, we're focused on the performance monitoring and reporting space, the assurance space, and we're really here to help customers provide visibility of their virtual services and their legacy services as well, combined to their end customers, help them reduce the risk of the virtualization and rollouts of it. And it's all due to, of course, all the transformations associated with NFV, SDN. There's a question right now about LSO as well out there as well. So really a big focus on the assurance space. Next slide, please. So what are some of those cornerstones? Well, when it comes to successful keys in SDN and NFV, it really comes down to the performance metric collection, the ability to real-time visualize it and then analyze that and then orchestrate on that and provide action and key. And that's really all about the Ocker IP suite that we provide. It's really true end-to-end circuit and virtual network visibility, being able to paint a single pane of service delivery services to the end customer. The end customer can simply log into a web portal, visualize the performance of their services. And a good example of that is there's a lot of discussions about the RAN space and the mobile backhaul space. And oftentimes these networks are interconnected through a series of different, actual carrier networks or infrastructures. And you can manage all that just by representing it all as on net for management purposes, so that you can make the right decisions to visualize and then orchestrate and take action on it. The things that we really focus on here is really on the SDN space is really the whole system automation, the lifecycle services of it. So if you see on the right side here, there's 3 green boxes. The self-service web portal, if you will. Okay, that's the part that customers can log into, self-subscribe to services like reports, visibility, decide to make dynamic on-demand actions. The middle part really is all the technology vendors, designing and virtualizing their systems in space. And we're wrapping our services around it so that you can get the performance assurance that's needed. And then, of course, the end-to-end and per operator monitoring as well. And that's really the LSO side. This picture is actually taken from the MEF. So just for those that aren't quite familiar with it, this is the lifecycle service orchestration components of it. And all the APIs are being built to be open standard to allow for communication between all these different layers. A couple key examples here of what Acura IP provides. Number one is a customer self-subscription through, again, that customer portal, but bandwidth on demand. It really sets the foundation for SDN and NFV. One here, customers can log right into the portal of a carrier's environment using Acura IP. They can look at specific mobile backhaul links, for example, and decide that they need more capacity, or they can build a policy that says we need more capacity in the service if our performance metrics start suffering. We'll then orchestrate that change when the customer makes a demand change request, and we'll go through a series of policies and audit control, perform the orchestration request with the SDN or network controller. The network change makes a change in real time. We'll version it, make sure that that change is successfully completed, perform that change control, and then integrate with their actual billing system as well. So full turnkey integration across the board with a carrier's billing and provisioning system also. And there's no free bandwidth being given away. The change is made. We really reduces the risk across the board for this example. And we offer this service today through a series of technology partners that we have partnerships with. And it really sets the foundation for the whole lifecycle service orchestration SDN and NFV space. Second slide here shows a different example. Scenario number 2 is, this goes back to what I made a statement on earlier, is that the carrier's challenge too is that their customers are demanding and wanting to know and be assured that their virtualized services are going to perform better, if not the same as their current services, legacy services that they're purchasing. So the other aspect of what we do from a performance assurance side is not only manage like the mobile backhaul links, the circuits, the capacity, the performance metrics of it, but as Mikola talks about rolling out virtual CPE, which is a great area, and this year I think you'll see a lot more rollouts in from the NFV space, is ensuring that the services, the VNF services, like the firewalls, the optimizations, the border controllers, that they are functioning at peak performance, while at the same time, since there are multiple virtualized applications running on that virtual CPE, that the appliance itself or that open box, that the physical and virtual vCPUs and the physical cores associated with it, the memory, the space allocation is all met to the SLA requirements for those applications, so that the overall end-to-end service is being met and provided to that end customer. And that's what we really mean on the SDN and NFV orchestration and full VNF assurance space. So that's just a little bit highlights of the Acura IP solution. Again, just kind of take in mind that it focuses on performance assurance, especially in the virtualized space, and at the same time providing that full visibility through a customer portal to carriers and customers.
Very good, Raymond. Thanks so much for the insight there. Great insight as well. But so yeah, what we're going to do now is get to some of the questions here. I had some questions set aside, but it looks like we've got quite a few questions that came in from our audience. So we'll get to those ahead of my questions, because I'm going to guess my questions aren't nearly as exciting or as interesting as those from the audience. But again, I want to thank our panel members for the great insight as well. And also a quick change up here for Sonus. Mick had to go to a different meeting, and so we've got in his place Dan Teichman, who's going to answer any questions from Sonus. So Dan, thanks for joining us as well. We appreciate it. He's in there somewhere. Okay, very good. Well, let's start with the questions here, and maybe the first one that came in from the audience. I know this. I think Ian touched a bit on this initially, but we had a question about the impact virtualization is having on the RAN domain. And I know, Ian, you kind of touched a bit on this, and the fact that obviously the RAN is going to be perhaps a bigger challenge for some of the operators. But I guess I don't know if you want to quickly, summarize kind of what you said earlier about maybe some sort of impact on RAN when it comes to the move towards virtualization.
Right. So, I mean, it's a good question, and it's a great area for discussion, because, of course, that's where the majority of the cost for an operator is, as we said. There are solutions out there. There was a company a couple of years ago actually showed literally a PC platform running a base station. Mm-hmm. You can build Cloud RAN where you put the baseband units or sit up in the cloud, and you connect them then through to a remote radio head at the local cell site. And obviously gives you a lot of flexibility. You need a lot of fiber to do that. But I mean, those discussions were happening 2, 3, 4 years ago. The problem, as I said, is that we've got all this incumbent infrastructure sitting there, and there's really no reason to go disrupt it. So what's going to be the disruptor or the trigger, I guess, that's going to move it towards a virtualized RAN? 5G could be that. So one of the aspects of 5G is massive densification of cell sites. Well, if I'm going to go put in 100,000 cell sites, maybe I want to look at a Cloud RAN solution, certainly remote radio head with the basebands in a local data center. If I'm doing that, then maybe now I've got to start pushing content out towards the edge of my network to make it more efficient. Maybe I want to look at some virtualized solutions there. So because you're upgrading a large part of the RAN or deploying new large parts of RAN, that's a good reason to go look at a virtualized solution today, because there's nothing else there. If it's sunk cost, it's already in the ground or up the tower or in the air.
Yeah.
You know, a lot of times there's no reason to rip it out. And so it's simple economics come into that. And I'll give you one last example. I do know of a couple of companies who are building in-building solutions right now, and doing exactly what I said, putting in-building small cells, DAS, hosting all the base stations in a local data center. Now the carriers are starting to come to them saying, well, can I get some extra space in your data center to put in my own solution, virtualized, etc. So in building, big area of build and focus, because coverage is pretty poor. Again, go build the most modern solution you can. And a lot of times that is virtualized or Cloud RAN, etc.
Yeah, makes sense. Well, maybe from Raymond, maybe from your point of view, obviously from the vendor community. I mean, is the technology there? I mean, are you seeing requests from operators to really, drive virtualization this far and this deep into the network, or what are you seeing today as in terms of a request, and I guess how far do you think this can actually be deployed throughout a network?
Yeah, I think that's a very good question, and in regards to what we see, especially from an end user community standpoint, is the wireless operators there are starting to definitely look at driving virtualization into the RAN space. Maybe not always down to like the virtual base stations perspective, but definitely in currently RAN deployments, how to optimize that infrastructure, reduce their costs, and also offer virtual services to really enhance the efficiency of their infrastructure, which really helps them reduce their costs by lowering the capacity requirements out there for the backhaul part of it. But it's still kind of pretty, still very new out there as well. They're all kind of just looking at it or really asking the technology manufacturers of the world out there, is there really virtualization solutions that fit that well? And I think the Ian's point is, that part of it's going to be a little bit more longer term. And so the solution sets that are going to be rolled out are going to probably be next year or the following year. The proof of concept this year really focused on the easier low-hanging fruit areas like the packet core first, and then pushing its way out into the RAN space. Now, from a consumer standpoint of carriers selling to enterprise customers and consumers, definitely on the virtual CPE side is a very large area of focus this year, and there will be a lot of deployments associated with those kind of virtualized deployments. The VCPEs could be a combination of smarter virtualized applications that run on these larger virtual CPE units, or it could be more of a lower end virtual CPE that's deploy the customer, but then the solution of all the virtualized applications are centralized back at a data center location for hundreds of thousands of customers that are being rolled out.
Yeah, makes sense. Well, not to change topics on it, but I know, Dan, I know from you're a little bit, disadvantaged because it was Mick's presentation there, but someone did send out a question for Sonis asking, is anyone suggesting NFV orchestration for distributed work or education or health? And, again, I'm not sure if that's something that you've got maybe direct knowledge of, but are you seeing, any sort of, work in terms of requests from that point of view?
We are. So I was listening to Mick's presentation, so I'm okay with that. So we are seeing customers asking. We're certainly engaged in people in both of those spaces, in both the healthcare industry as well as education. Less so about what I'll call the distributed work domain. Unless I suppose we could go off tangent and talk about content, things like that. But to bring it back, the fact is that there aren't a lot of enterprises who are moving any faster than some of the large carriers. Some of the large enterprises have exactly the same concerns about disrupting their revenue streams and things like that. So while I think people are absolutely, enterprises and service providers are absolutely on board with, there's a better way for me to do things, I think they're all, and I think I can quote either you or Ian from earlier, they're dipping their toe in the water and seeing how it works. So, we do actually have one customer who, to use Mick's example, the virtual CPE, session border controller as a service, they're actually hosting in their cloud environment session border controllers, and one of their customers is someone in fact in the healthcare industry. But again, it's it's early stages. It really is. I mean, I think the model plays well for virtualizing these functions, whether again it's the EPC functions, it's the virtual IMS functions on the mobile side, or in the case of this question, for example, healthcare, education. People are willing to move in that direction, but I don't think they figured out how quickly and how much work it's going to take. And I think I'll even add one more point, which is service providers, I think, have a real good opening to support those large enterprise customers by saying, I'll solve that problem for you. Let me show you how I can do it and make you a better enterprise customer. Yeah,
that makes sense. Well, great insight there. Well, again, we got a lot of great questions that have come in on this. I'm going to try to consolidate a couple of these here and maybe those from Ian a little bit. I know, Ian, we talked a little bit about this when I was working on this report too, but we have some people kind of asking about, I guess, the incumbent environment in terms of vendors like Ericsson, the ones that are out there now, basically, as they try to, I guess, move towards this virtualization new model. It's a challenge for these guys because, again, they do have these legacy business or I guess business models in place, which, as you mentioned earlier, kind of rely on service contracts and things like that. I guess as we look at the environment in terms of vendor space, I mean, what's this evolution, and is this a big, I guess, holdup, or what's the holdup to kind of these bigger vendors getting more involved in terms of the rollout of virtualization out there?
Yeah, I mean, you're right, and I think the answer is they've got shareholders. I mean, the reality is the big vendors, they may want to do many different things, but when push comes to shove, they're going to do what AT&T, Verizon, China Unicom, Vodafone, Telefonica, etc. want to do. That's who their customer base is. So they can only move as fast as the operator will let them move. And in many cases, the operator may want to go in a different direction from the one the vendor wants to go in, right?
Yeah.
So you and I were talking earlier about AT&T has just built a eComp, I think it is, a new platform that is vendor agnostic. They've developed it themselves because they couldn't find anything in the market that did what they wanted to do. Mm-hmm. Well, that really doesn't help the vendors when that happens, but obviously for AT&T's got to do what it needs to do. So I think at the end of the day, the problem is we do have vendors, they do have P&Ls, and they have product development timelines. They frankly have sales people as well, and I mentioned a couple of examples of, I know there's cases where a vendor offers a virtualized solution for a piece of the network, and yet, the carrier actually ends up buying old iron from the same vendor because the sales guy needed that box checked on his quarterly numbers. And there's depreciated hardware that has long maintenance cycles, which is good revenue for the vendor. So it's a legacy business versus a new business. It's a transformation. Having said all of that, when you look at the vendors today, be it Nokia, Huawei, Ericsson, and I'm missing lots, obviously Cisco, et cetera, they are big enough and they have shares. They can go acquire new technology. So when they need that new piece of virtualized solution, whatever it is, they can go acquire the relevant company and then move into that direction. Cisco, of course, has been built over very successfully acquiring and integrating. And I think that's what you'll see here is we don't need the big vendors to go recreate everything themselves. There's a healthy ecosystem out there that when the time is right and they need that revenue stream and that solution, they can leverage their stock to go buy it. And by the way, I'll answer one last point. I mentioned 5G with CRAN. One of the comments was you don't need to wait for 5G for CRAN. You're absolutely correct, but you also cannot have a webinar these days without mentioning 5G. And yes, you can do CRAN with all the different technologies, and you will see it with higher orders of LTE over the next couple of years. We don't have to wait for IMT 2020. We can do it release 11, 12, 13 of LTE. There you go.
Good point. Getting the 5G node in there. And actually, we haven't mentioned IoT yet, which I think we have to also mandatory. Somebody
will mention. I'll leave that to the other guys. Somebody needs to throw that one in.
But I guess maybe on that topic as well, maybe from Raymond, obviously it does seem like that, again, it is a very diverse vendor community out there when it comes to virtualization. I mean, are you guys seeing good cooperation from the various players, whether they're the legacy kind of old school or whatever I call them, telecom guys, and some more innovative companies? I mean, are you seeing some pretty good collaboration out there between all the different vendor partners when it comes to working towards this common goal of what the operators need in the market?
Yeah, especially, when we work on the Aker IP platform with all the different vendors and technology companies out there, we really see three areas that they're kind of maturing their virtualization solution in terms of interoperability, integration. One is, they are doing their own research and development and doing their own software coding to provide in an open source manner to allow for integration with their new systems that are coming out. The second area that we see a lot of is in trying to integrate their legacy systems, because they know that their customers have such a large legacy system base of infrastructure and technology deployed, and they don't want to lose that anytime soon. Like Ian was saying, they do report to their shareholders as well. They want to maintain that legacy infrastructure and even sell more of it if possible, right? So they're trying to develop, integrations of legacy systems, and obviously that's more proprietary, not so much around interoperability. And then the third area is really trying to contribute open source code into standards bodies like the MEP, for example, for LSO API, so that their technology can be showcased, if you will, and easier to integrate with, systems like Aker IP to provide that integration with their technology set. So we really see three areas and three roads that the manufacturers typically are, looking at deploying their interoperability and also offering their management and integration capabilities through APIs too.
Makes sense. I guess maybe jumping off of that as well, maybe a question for Dan. And we have some questions coming in about this. Is I guess the standards issue on this. I mean, are you guys seeing? I guess the standards bodies. I mean, obviously ETSI is kind of seen as one of the major standards bodies when it comes to this move to virtualization. But there's also a lot of different organizations working towards this as well. I mean, are you seeing good cooperation there in terms of those bodies being able to really, I guess, keep pace with what needs to happen out there, but also take into account all the various vendors and points of view in terms of the technology out there? Are you seeing good progress there?
That question covers an awful lot of ground.
And you've got 1 minute, so good luck with that. No, I'm just kidding.
So I think there's a lot of people committing a lot of time to get the standards bodies, moving forward in a cohesive direction. I mean, ETSI has certainly done a lot of work laying out the frameworks, but I mean, to the point earlier about, I guess Ian made it about people moving, or you did, carriers moving faster than some of the standards bodies. Yeah. I do think we're going to see a lot of pre-standards deployment work going on. We certainly are hearing about it. I think from our perspective, we are, I'll say, a half a step removed in that a lot of the standards that we are tied to, the VoLTE, the IMS, the things that are SIP and IP related are fairly well established. I think a lot of some of the new standards and some of the NFV domain and some of the orchestration, again, as Mick had showed, we're part of an ecosystem where orchestration is picking us up and making our VNFs real. So I think for us, it's a relatively easier view. But I mean, we certainly hear the stories about multiple people trying to join all of these organizations so they can all have a voice in the battle, because none of them want to lose, what could be a long-term evolution plan for them all.
Yeah, and I know I've talking to some operators about this as well. I mean, that's been kind of their biggest concern, is that they feel like they have to join all these organizations because they do want to have a say in what's happening. So they are kind of being stretched to kind of join all these different organizations out there and really be part of what's happening out there. So I think we might have time, I guess, here maybe for one more quick question. And this will be for Ian here. Somebody had sent in a question asking about, do Cisco and Juniper have more to lose from NFV than the base station guys, and what about white box? Maybe Ian, if you want to do a quick response to that before we wrap up the webinar here.
Yes. I think the thing with virtualization, everything we're talking about is we're not just talking about one piece of a network. We've been talking about enterprise and carriers and packet cores and radios. Everything is impacted by virtualization. And if everything can run on standardized off-the-shelf hardware sitting somewhere, then all aspects of this industry, the telecom, let's just take the telecom industry, get impacted. So nobody's immune. And plenty of white box vendors out there coming in with a solution, runs on Intel hardware or whatever, yeah, it's going to impact everybody. The packet core, let's just take the packet core as one little example. You know, not many years ago, that ran on dedicated hardware using highly specialized software. And everybody said, you cannot take a packet core and put it into a data center and virtualize it until somebody did it. So, you know, never say never, but no, I mean, what the carriers here are talking about is ripping apart their networks and redeploying them. And that's why the standards for this become so critical and so, frankly, so difficult. To your last point, only a few people can drive this because they've got the experience and they've got the people. The biggest challenge AT&T had in virtualization was actually retraining all their staff.
Yeah.
I mean,
that's a whole different topic. You're right. I mean,
whole different topic. Yep.
Yeah,
yep.
Yeah, you're right. That's talking to those guys. They even say that's one of their biggest challenges, just retraining all their employees to this new model. So that's a whole. I mean, that's something there. But again, we definitely appreciate the insight on all these questions. And looks like we've got tons more questions that came in. A lot of good ones about security issues, which are obviously a big part of this going forward as well, and standards and things like that. But what we're going to do is we're going to share all these questions with our panel members for possible follow-up after the webinar here. So hopefully these questions will not go to waste, and we'll try to get some answers for you guys on those as well. But I definitely want to appreciate, thank us, I should say, our panel members, Ian, Dan, and Mick, and also Ray from Local Backhaul for providing great insight today. Thanks, guys, so much for the time and insight on this. Definitely appreciate it. And also, I'll recommend to all those who are listening in to you can go to the rcrwireless.com site. We should have the report connected to this up on the site here very shortly. There's some insight in there from these panel members as well as some other topics in there. So I definitely recommend you download that report. But like I said, I want to again thank everyone for joining us today on the webinar, and again thank our panel members for joining us. And thanks everyone. Have a good afternoon.
Thanks, Dan. Thanks everybody.